Hello and welcome to our session today on the Microfocus point of view around low code and no code for UI test automation. My name is Don Jackson. I'm a chief technologist here at Microfocus. And this session is really going to talk about how you can use UI test automation using the principles from software development concepts of low code and no code. From an agenda perspective, we're going to first talk about what is low code and no code for application development. We want to first establish what are the terms and what they mean, and then we'll drill down into those concepts and how they can apply to UI test automation. We'll also talk about codeless versus code suppressed, which seems to be permeating the marketplace right now. And then finally, we'll intersperse demonstrations of low code and no code for UI test automation into the presentation. First, we need to establish what is low code and no code for application development. First, according to Gartner, specified in Gartner ID G00745-717, low code is a RAD, or rapid application development capability, where the solution being used generates the code or the script that you can modify, and then you can assemble that code into a model-based or model-driven environment. And the goal here is to provide a mechanism for less technical people to be able to contribute to robust applications. Secondly, no-code development are tools that abstract the code entirely. So you can't get to the code, and you're really getting a WYSIWYG, or what you see is what you get interface to build your application. If you can't get the logic that you need from what you built, then you have to change what you build or your business logic to fit what the tool can handle. So let's drill down a little bit, comparing low code to no code and the characteristics of each. For low code is a RAD, or rapid application development framework, designed to enable release of the application with a faster time to market. In a low code environment, the application code is generated by the tool through selecting some abstracted component assembly or model or metadata or some combination thereof. And once the code is generated, the low-code solution should facilitate drilling into the code, allowing you to customize that code to suit your individual needs to whatever level of complexity that is needed or wanted for the application that you're developing. Now, typically, a low-code solution starts off with some kind of model where you select the component assemblies and then add them into the model and then generate the code once you're done with the model. And as such, usually you need some level of expertise in modeling. And the best low-code folk will have a significant level of modeling expertise to make the best use of their low-code framework. Now, one of the big benefits to a low-code framework is that when you need to get down to the code, due to some business logic complexity or market differentiated solution, or even new technology that you want to adopt to beat your competitors to market, given this, the coding expertise that you need may be low or could be as much as high, depending on what your individual needs are. And since you can get down to the code level, when the framework needs to be extended, the complexity of applications that you can create using a low-code solution can be as high as your business needs. Now, when we look at a no-code solution, they're also a RAD framework, so rapid application development. And typically, the framework still generates code, but that code is inaccessible. There are some solutions that use an at-runtime interpretive model to build the objects at runtime, but from a performance perspective, typically, there's still compiled code that gets generated and deployed. Now, this means, though, that the application you're developing will behave and look exactly how it looks in the modeling or development tool. So essentially, it's a WYSIWYG, or what you see is what you get. And since you can't get to the code level, and it's a WYSIWYG solution, you really need to understand and be well-versed in how to build and manipulate your model in order to get the application to look and behave the way that your business needs. However, since the code is inaccessible, and in some cases there isn't even any code that exists, the coding expertise that's needed is really none, or next to none. You don't need to know how to code or a coding language. Now, you do run into the limitation that when your business logic is highly complex, or you want to adopt some new technology widget, the framework that may not support it at that time, which ends up meaning that you have to either change your business logic or not use that new widget or open a ticket with the solution vendor and wait for a patch. Now that we've established what is low code and no code from an application development perspective, let's talk about how these concepts and characteristics are applied to UI test automation techniques and tooling. First, let's look into the low code perspective. How do those low code characteristics that we talk about apply to UI test automation? Firstly, the concept of RAD, or rapid application development, can be applied as rapid test script development. It should speed up the time it takes to create tests as opposed to a fully coded solution. And just like for application development, the code gets generated by the tool. Additionally, any low-code solution that's worth your time and effort should allow you to get down to the code when you need to. If you have some complex business logic in the framework, and that framework doesn't support that complex business logic, you should be able to simply switch to the code and add in the logic into your code as necessary. Now, a lot of low-code UI test automation doesn't require you to do any modeling, but depending on your situation, you might be leveraging some kind of model-based testing solution in conjunction with your low-code UI test automation. So the old adage of your mileage may vary when it comes to the modeling expertise applies here. In that, in order to be successful with your low-code UI test automation solution in conjunction with whatever model-based testing solution you're using, you may need some modeling expertise or you may not. And just like low code for application development, the level of coding expertise that you need is also going to vary by what your individual needs are and your individual role within the company as well. The good low code UI test automation solutions will allow you to add to and or customize the framework to enhance the low code capabilities. And that ensures that your less technical folk can still leverage custom capabilities that you need in your framework. If you don't need to customize the framework or your role doesn't require you to get down to the code, your coding expertise needed could be quite low. And then lastly, just like the maximum complexity of applications that you can create with a low-code application development solution, the maximum complexity of tests that you can create with a low-code UI test automation solution is also very high. So let's look at a low-code UI test automation implementation in practice using ALM Quality Center in UFT1.
Okay, so now we're going to show a low-code implementation of UI test automation. So what you see on your screen here is we have ALM Quality Center that's up and running, and it has the manual test that's already defined for logging into our Advantage Online shopping application. So this is our application under test. And you can see it is in the state where it is not logged in. So what we're going to do is we're going to go in here and we're going to click the Generate Script button and generate the UFT1 script. And then you can click on the Test Script tab and you can see what it's generated. What it's done is it's taken all of the manual steps and created comments and a reporter event for each individual step for it to go through and run through this step. And the reporter event is so that you can have that report out to the UFT1 log. And now inside of UFT1, you can see what this looks like. Now, like any good low-code solution, there is code that is generated, and you can get to that code if you need to. So you can click this button here, and you can actually get down to the code. But we're going to stay at this higher abstraction layer. And what we're going to do is, what we could do is you could do, as it states here, do a recording. So you could do record, enhance, and playback, which is the way that we've done test automation for many, many years since the 1990s. But instead of doing that, what I'm going to do is I'm going to show how you can learn objects in the object repository and then drag those and have it create the code for you. So I'm going to learn the object here. So I'm going to learn my profile icon, and I'm going to give it a meaningful name so that it's easier for me to read my script. And I can simply just drag this item over to where I want it in the script. So you can see it's created the code for me. I'm going to go through and I'm going to learn the other objects that I need to work against. So the business process here is to log into the application. So first I have to enter in the username into the username field, I have to also interact with this password field. So I'm going to learn that object as well. And I'm going to give it a meaningful name. And then I also have to click on the sign in button. And I'm going to give that a meaningful name as well. And now I can just go through my script and I can drag these over and have it create the code for me. So I need to log into the user, enter in the username. Now I have to enter in values, right? So I'm going to set the value to be my user ID. And I need to go through and enter in the password. So I'm going to drag that over as well, just like I did before. I'm going to put in my password. And then I'm going to click the sign in button. Now I've got this created. The last thing that I need to do is I need to do a configuration on here and tell it where I want to log into, what application I want to hit. So I'm going to hit that, copy that URL, and I'm going to put it into my settings to say I want it to use Chrome because no one ever uses Internet Explorer anymore, and I'm going to give it the URL. So now I can save this, and now I've automated my script, and I haven't touched any code at all yet. And this is capabilities that have been inside of ALM Quality Center and UFT1 for many years, probably over 10 years. So now I'm just going to go ahead and run this test, and you can see my test passed. And with that, that is a low-code implementation of UI test automation. And if I refresh it back in ALM Quality Center, because I saved it in there, I can now see that inside of ALM Quality Center as well.
Now, if you want to test a low-code and or a no-code application using your low-code or no-code UI test automation solution, you need to leverage AI computer vision capabilities to recognize the objects on the screen. Otherwise, when the RAD or rapid application development change happens, where all of the underlying object properties of the objects change, your test automation will break. Now, here's an example of how you could convert a properties-based low-code UI test automation script into an AI computer vision object recognition script.
So now we're going to take this low-code implementation script that we created using UFT1 and ALM Quality Center, and we're going to infuse AI objects into the script to make it even more resilient. And the way that we're going to do that is there's a flag inside of the options for GUI testing for AI that's called the AI Transformation Assistant. And you can click this checkbox, and what it does is it replaces the run results on the report with AI object suggestions if there are objects that are recognized by the AI engine so that you can make your script more resilient. And all we're going to do now is we're going to play the script again. So this script is now going to execute, and what it's going to do is it's actually going to look at every object that is being touched by your script, take a picture of it, highlight it on the screen for you so you can see what it's acting against, and it's going to check that against our AI engine to see if that object could be recognized by the AI engine. And if so, it's going to suggest what statement you could put into your script and replace the existing statement so that you could now leverage the AI capabilities. So our report's now done, and you can see in here that it tells me what steps I can replace. So like any good low-code implementation, I can switch to the script level, and this is an example of when I would want to do that. And what it's telling me is I can replace this statement that's right here, which I can see is right here, which is line 7, and I can replace it with this statement that's here. So I can just simply copy that and replace the statement that's in there. And if I go through and I do that for all of the statements that are in here, so right now I'm doing the entering in the value of the username into the username field for the user, and I'm going to do the same thing for the password. And then I'm going to do the same thing for the sign in button. I now have replaced all of my statements now with AI statements. The other thing that I could do is, if I'm sure that I'm not using these objects anymore, I could go into the object repository and remove those objects that I'm no longer using. So I'm going to remove and go in and delete these from the object repository. And I can actually, because I'm not using the parent at all, I can delete that parent now as well. And you can see I now have nothing in my object repository. So before I run, though, I want to make sure I go back and change that setting back to make sure that I'm using my standard report instead of my AI transformation assistant. And I can close my browsers and I can rerun my test. And I could go back into my keyword view, my low code view, and click run. And what you'll see is my test is now going to run, now using AI objects instead of using the traditional property-based objects. And the advantage of this is using the AI objects, if those objects' properties change, which they frequently do. Anyone who's done test automation in the past knows that. Those, as long as the visual characteristics are still the same, my script will still continue to work. And you can see that my script has completed, and you can see in the report what it acted against. And with that, you've seen a reason why you might want to drill down to the code level is to change it to an AI-infused script.
Now let's look at it from a no-code perspective. How do no-code characteristics that we talked about earlier, how do they apply to UI test automation? First, the concept of RAD can be applied as rapid test script development, just like it can in a low-code comparison. It speeds up the time it takes to create tests as opposed to fully coded solutions. And while typically the application development no-code solution still generates and then delivers finally then compiled code to allow for fast-performing objects in the UI test automation no-code environment, there should be no code generated at all. The quote-unquote script should be represented in near plain English, and it should leverage AI, natural language processing, artificial intelligence, NLP. And what it should do at runtime, it should interpret what was written into the commands that the tool uses to drive the automation. The value proposition for a no-code UI test automation is that you can drive automation into the hands of the non-technical, very non-technical resources. Those same non-technical resources are usually familiar with business process modeling, and as such, it makes sense to marry no-code UI test automation with a model-based testing solution. Now, while you don't necessarily have to build your tests in a modular or model-based manner, the persona who typically would utilize a no-code solution would also naturally gravitate towards and reap the benefits from a model-based testing framework. Thus, the modeling expertise that's needed could be low, but it's more valuable when you have a high modeling expertise. And just like no code for application development, the level of coding expertise that you need will be none, since frankly, there's no code. And lastly, just like the maximum complexity of applications that you can create with the no-code application development solution, the maximum complexity of tests that you can create with a no-code UI test automation solution is also medium, because you will, at some point, run into some complex business logic that the framework just doesn't support. Now, ideally, you'd have something like the Micro Focus solution set where you're able to switch that particular business process to a low-code solution at that point, in this case UFT1, to handle the highly complex business case. And then you could still leverage your no-code solution for the lower complexity, the low to medium complexity business processes. Now, before we jump into a demo example of a no-code solution, we need to talk about what's going on around the quote-unquote scriptless solutions in the marketplace, or what I call code-suppressed solutions, as opposed to codeless or truly no-code solutions. First, let's set up what a truly codeless solution looks like with the Micro Focus AI codeless solution, a lot of which is a reiteration of what we just talked about. Micro Focus AI codeless is a no-code UI test solution. like what we talked about in the previous slide. There is no code. The test script is in near plain English, and it utilizes AI, NLP, or natural language processing to, at runtime, translate what was written by the tester into actionable commands for the tool to execute. AI Codeless actually comes with our model-based testing solution for 2 licenses, and it's delivered within our Value Edge platform. And within model-based testing, you can have models comprised of low code, the UFT1 scripts, and other models in the same instance of no code or AI codeless tests, all executed by the same test suite. This means that when you run into a situation that you really need the flexibility of a low code solution for a specific business process, and you can go and implement that individual business process with your low code or UFT1 scripts, and then have all the other business processes leverage the benefits of no code or AI codeless scripts. Now, there are some folk out there who tout their quote unquote scriptless solution, which can be, frankly, I find it deceiving, making you think that they are talking about a truly no code solution like our AI codeless solution. Unfortunately, these quote unquote scriptless solutions are usually actually a low code test automation solution, where the tool is actually generating code. They're just hiding it from the user or suppressing it. The code is generated, but just completely inaccessible so that they can tout being quote unquote scriptless. These solutions also tout being quote unquote shift right solutions and offer model-based testing solution within this scriptless automation. But even their model-based testing solution, frankly, is suspect, being much closer to using an object repository and dropping those objects into a script, similar to what we showed in the low-code demo with UFT1. And because these low-code solutions are suppressing the code, unlike the micro-focus solution set where you can fall back to from the no-code solution into the low-code solution, having the code suppressed means that when you run into these situations where you end up having to either change your business process itself, or you have to open a ticket with the vendor and wait sometimes weeks or even months for a patch to be delivered. So you really need to dig into the solutions that you're investing in and investigating to determine if this quote unquote scriptless solution is really a code suppressed solution or not. You don't want to be stuck with a low code solution and not be able to reap the benefits of being a low code solution and get into the code when you really need to. So now let's take a look at an example of a no code solution, the Microfocus AI codeless solution delivered as part of our model-based testing solution within the Value Edge platform.
Now we're going to show a no-code implementation for UI test automation. So no-code starts from the model. So we're going to look at a model real quick. So this is a model for our Advantage Online Shopping demo application. And within that, we have one model that calls another model. And in that logged in flow, we have this login component or unit. So we're going to go ahead and navigate to that login component or unit. And we're going to look at the script inside of our model-based testing solution. So this is the codeless script that's in there. And we're going to go ahead and launch the editor. And as you can see, this is in near plain English. There isn't any code to go to. There isn't any code underneath this. It's all about configuration and no actual code that's going in there. So you can see here's the configuration for parameters. Here's the configuration for individual steps. Here's the configuration for what application you're going to use. Now in this particular case, I have it set so that this script relies on the previous application that's actually the previous step that's already launched the application. So I'm going to launch the application manually so I can show it executing. And you can see here, it's just simple, near plain English. Click the profile, type the parameter of the user ID into the username input, the password into the password, click the sign in button, and then verify that it's there. So I can go ahead and run this, and you can see it execute that same business process of login here in an automated fashion with no code being existing. There is no code. It's actually using AI, artificial intelligence, natural language processing at runtime to translate, click the profile into what would be executed by the application. by the automated test. And you can see here that same report that we're all familiar with UFT1 and other UFT tools and how it's executed that. And that is an implementation of a no-code solution.
We have another video on our YouTube channel around our point of view for model-based testing, but I thought it would be helpful if we do a very brief overview, since to get AI codeless, you need to utilize MBT or model-based testing. Model-based testing is a software testing technique in which the test cases are derived from a model that describes the functional aspects of the artifact or artifacts under test. This means that rather than relying on the intuition of the individual tester to determine what functionality to test, the business processes that they're going to test are represented in the model, and the underlying individual functions that comprise those models drive what should be tested. Typically, the model can, but doesn't necessarily have to be, displayed in a visual format, making kind of like what you see on the screen here, where I've obfuscated the actual text, because the text doesn't matter, it's really the flow that we're talking about. And this makes it easier to understand what is the business process that's planned to be tested. And with that, I want to thank you for taking the time today to listen about our point of view around low-code and no-code implementations for UI test automation. I hope you enjoyed the session, and I've included a QR code here to the model-based testing video that I referenced earlier. Have a great rest of your day.